Okay, practice tonight was 2, 5, 6, and 8. Let's run through problem number 2. How many moles of H2SO4 are in 2.5 liters of 4.25 molar aqueous solution? Well, remember that the 4.25 molar means for every 4.25 moles of H2SO4, there is 1 liter of H2SO4 solution. That's what that means. So that means that if we had 1 liter of solution, there would be 4.25 moles in it. Right? 1 liter. So that means that now they're saying, what if I had 2.5 liters? Well, would we have more moles or less moles? And if we kind of think about this as a forever statement, or just logically, well, if we got more liters, we would need more moles. So if we set up our forever statements, then we can just go down. It would be 2.5 times as much. So 4.5 times 2 would be 8.5. And then half of 4.25 is 2.125. So if I add those up, that comes out to be 10.625, which would be 10.6 once we round to sig figs. Okay, and then problem number 5 asks us what mass of anhydrous cobalt 2 chloride would be needed in order to make 650 milliliters of 4 molar cobalt 2 chloride solution. Right, so I'm going to just draw a picture here. So they want to know, they want us to have 4.00 moles in 1 liter of solution, and they don't want to make a whole liter. They only want to make 650 milliliters, so 0.650 liters. And they want to know how much solid we add to make this. Okay, so let's write our forever statement. So we know that we want to make a 4 moles, for every 4 moles of COCl2, solid COCl2, there is 1 liter of COCl2 solution. And we don't want to make a liter. If we wanted to make a liter, we'd add 4 moles of this stuff, but we don't. We want to make 650 milliliters, so 0.65 liters of solution. So we want to make a proportion of this. So this, I'll just do it times 0.65 times 0.65. And so 6/10 of 4 would be 0.24, plus half of 4 would be 0.2, so this would be 0.02. So this is 0.26 moles of COCl2. And we're not done yet. So we know that we've got 0.26 moles of COCl2. And there's some number of grams of that is what we're looking for, because they asked for the mass. So we're going to say for every 1 mole of COCl2, there is, well, we got to look it up on our handy dandy periodic table. So I pull out my periodic table and I notice that CO is 59 about, and Cl is 35.5. So we've got 59 plus 71 is 130. So there's 130 grams of COCl2. If from 1 to 0.26, I'm just going to multiply it by 0.26. So I'm just going to multiply this by 0.26. So that's about a quarter. So half of 130 is 65, and half of 65 would be 32.5. So I feel pretty comfortable saying 32 grams of COCl2. Okay, question 6 says that you want to make a 0.15 molar solution. So let's draw that up here. So we want to make this be 0.15 moles per liter. Okay, and they say, look, I've got a beaker over here, and I'm going to add 11.27 grams of AgNO3 to it. Okay, so I got solid stuff. I'm going to add it into here. I want it to break apart, and I want to get this to be the proportions. So they want to know how many liters do I need to fill it up so that these are the proportions. So again, let's go back and think about this. We need it to be 0.15 moles of AgNO3. That's how much, if we evaporated off all of this, so there'd be 1 liter of AgNO3 solution. Okay, and then down here, well, we've got for every blank moles of AgNO3, there is blank liters of AgNO3. Uh-oh, we've got 2 unknowns right now. But we do have one other piece of information, and that's that 11.27 grams. If only there was a way to convert from grams to moles, and I think you should know that there is. So let's do that real quick. We know that for every 1 mole of AgNO3, there is some number of grams. So we'll pull out our anti-periodic table. And when we do that, we find that Ag is 108, N is 14, 108, and 3/16. So we've got 108, 14, and 3/16 would be 48. If we add all that up, 170 grams of AgNO3. And then for every, well, we've got 0.15 moles of this stuff. Blank grams. Oh, sorry, we don't have 0.15. We have 11.27 grams of this stuff. This is the solid AgNO3. And the difference between those two numbers is about a 15th. So this is divided by 15, divided by 15, and 1 divided by 15 is 0.0667 moles of AgNO3. All right. So I'm going to go back up here. Get rid of all that. Go back up here. And I'm going to say this is 0.0667. And I'm trying to figure out the liters here. So that comes out to be divided by 2.25. And I'm going to divide this by 2.25. Should be pretty close to a half. 444, or 0.444. So we need to add, for this part, we need to add 444 milliliters to the 11.27 grams. And the last problem, what mass of barium nitrate is dissolved in 21.29 milliliters of 3.38 molar solution? So remember that this 3.38 molar solution means that in 1 liter there would be 3.38 moles of barium nitrate, so BaNO3 2. So that would mean that if we evaporated off a whole liter of this stuff, right, we would end up with this many moles of this. Okay, well, we don't have a liter of it. We've got a lot less than a liter. We just got 21.29 milliliters of it. So we've got a fraction of this liter, which means that we have a fraction of the number of moles. Okay. Another way to think about this is how many grams of this stuff would I have had to dissolve in here in order to make this proportion be true. Okay, so I'm going to start off, I'm going to say for every 3.78 moles of solid BaNO3,2, right, there is 1 liter of BaNO3,2 solution. Okay, and then I got another forever statement down here. I've got for every blank moles of BaNO3,2, there is blank liters of BaNO3,2 solution. So what we're really looking for here is we're looking for the proportion of to get from here to here is going to be the same as the proportion to get from here to here. So this is going to be 0.02129 liters, right? So times 0.02129 liters times 0.02129 liters. Well, if this was 2/10, that would be pretty easy. That would be 0.378 plus 0.378. So let's just make it 0.38 because it's a little bit more. That would be 0.76. So if it's 2/100ths, that would be 0.076. So it's about 3/4 or 3/40ths of that. All right, let's stick all this up here because we need to finish this problem off here. Okay, so now I'm not done yet. I need because they asked for the grams, right? So for every 1 mole of BaNO3,2, there is, let's pull out our handy dandy periodic table. And we see that Ba is 137 1/3, N is 14, and oxygen is 16. So we've got 137.33, 14 times 2 is 28, and then 48 times 2 is 96. So we got 261.33 BaNO3,2. So now we've got for every blank, which is 0.076 moles BaNO3,2, there is blank grams of BaNO3,2 times 0.076 times 0.076, and just make a box. Half of this would be 131, let's say, and 1/4 of that would be 65.5. So that would be 5, 6, 9, 196.5. This is pretty close to 3/4, except that it's 3/40ths, so it's 19.65. And that's how you do that math in your head. Okay, I hope that helps. See you guys tomorrow.